Good day. I am Nicole Ingrid Lusterio of BS Psychology. For today's lesson in Mathematics in the Modern World, we are going to discuss and talk about measures of dispersions, how to compute it, and its application to our daily life. We define that dispersion is a statistical term that describes the size of the distribution of values expected for a particular variable. This dispersion can be measured through range, variance, and standard deviation, and let's take a deep look to these measurements. As what is the definition of range display? We can simplify say that to compute for the range, we have to look for the highest and lowest value in the given set of data, then find its difference. For example, in the set of 4, 6, 9, 3, and 7, we can obtain that the highest value will be the 9, while the lowest value will be 3. Then we will have to subtract it as 9 minus 3, which is equals to 6. Therefore, the value of our range will be 6. Variance defined a given set of data is the square of the standard deviation of the data. The equation for variance of the population will be summation of x minus mu squared over n, while the variance of the samples equation will be summation of x minus mu squared over n minus 1. Standard deviation defined a set of numerical data makes use of the amount by which each individual data value deviates from the mean. Then the standard deviation of the population will be the square root of the variance population, while the standard deviation samples is also the square root of the variance sample. Okay, let's have the 5 procedures in computing the standard deviation. The first step, determine the mean of the n numbers. The step 2, for each number, calculate the deviation or the difference between the number and the mean of the numbers. Step 3, calculate the square of each deviation and find the sum of these square deviations. Step 4, if the data is a population, then divide the sum by n. If the data is a sample, then divide the sum by the n minus 1. The last step, step 5, find the square root of the quotient in step 4. Take a look on the example. The list of data that we obtain through random sampling from 0 to 31 are 27, 12, 18, 17, 31, 13, 22, 26, 01, and 24. The first thing we are going to do is to list the data in a tabular representation. Then we are going to find the mean. To get the mean, we have to find the total of the given data. In this case, the total of the listed data is 191. Next is to find the number of the given data. We have 10 different numbers, so the number n will be equal to 10. The formula of the mean is the summation of x divided by n, thus 191 over 10 is equal to 19.1. Next is to subtract the mean from the x, then square it. Our first value that we obtain is 62.41, the second one is 50.41, and so on and so forth. And the last value is 29.41, as you can see in the representation. Then get the summation of it. We get the value of 704.9. Take note, we round off our answer to the 2 decimal places or 100 places. Back to the topic. Next is we are going to solve for the variance. Variance is equal to the summation of x minus mu or the mean squared divided by n minus 1 because it is the variance of the sample. Thus, 704.9 over 9 is equals to 78.32. We are going to solve for the standard deviation by the square root of the variance. So the square root of 78.32 is equals to 8.85. So we can say that our value that we obtain is spread out. Let's have another example. The next example is to solve from the two sets of values. Let's have the set of A, which is 66, 61, 64, 65, 66, 68, 63, and 62. And let's have the set of B, which is 21, 40, 10, 29, 36, 17, 55, and 4. The first set that we are going to solve is the set A. The summation of x values of set A is 515 and the n is equals to 8. 515 over 8 is equals to 64.38, so that will be the mean. Subtract the mean or mu to the x values and square it. We obtain the summation of 37.84. Now, in the standard deviation, square root of 37.84 over 7 will be equal to 2.33. So the 2.33 will be the standard deviation for the first set. On the other hand, the set B has the total of 212 in X values and number of 8 obtained data. 212 over 8 is equals to 26.5, so that will be the mean of the set B. The formula of X minus mu squared, we get to the summation of 1990. Again, for standard deviation, square root of 1990 over 7 is equals to 16.86. So that will be the set B standard deviation. Take note, the smallest standard deviation is the better. So we can say that set A have the standard deviation consistency than the standard deviation of the set B. These examples for the application of standard deviation, wherein the standard deviation can determine the consistency through comparison. This next example is based on real-life example to show the importance of dispersion of the values. The reporter is analyzing the high temperature forecasted for two different cities. Which cities are much consistent in the terms of Fahrenheit temperature? Let's have the data recorded in a week in a city A and a city B. Here is the data recorded in a city A. 95, 93, 95, 94, 96, 94, and 95, while in the city B recorded the data of 90, 81, 95, 91, 86, 82, and 78. First, let's solve for the city A. The summation of x minus value of the city A is equals to 662 and the value of n is equals to 7. 662 over 7 is equals to 94.6, and this 94.6 is the mean. After calculating for the quantity of x minus mu squared, we're able to get the summation of 5.72. The square root of 5.72 over 6 is equals to 0.98. So 0.98 is the standard deviation for the city A. So now, let's take a look on the city B that has a summation of 603 and the n number of 7. Let's have to find the mean. So 603 divided by 7 is equals to 86.1. Subtracting this number to all the x value and square it, we're going to have the summation of 226.9. The square root of 226.9 over 6 is equals to 6.15, and that will be our standard deviation for city B. If we analyze the standard deviation of city A and city B that has 0.98 and 6.5 or 6/15 respectively, we can say that the city A forecasts are more reliable than the temperature than the city B. Here's another example to determine who is the most consistent scorer between the two star players in their team. This is the list of scores of 2015 to 2016 NBA Finals between JSW Stephen Curry and Cavs LeBron James. In the 7 games, LeBron James scored 23, 19, 32, 25, 41, 41, and 27, whereas Stephen Curry scored 11, 18, 19, 38, 25, 30, and 17. The points that LeBron scored is 208, and if we divided it by 7, we're able to get the mean or the points per game or PPG of 29.71. The summation of x minus mu squared is equals to 449.4. The square root of 449.4 over 6 is equals to 8.56, and that will be the standard deviation for LeBron James. Curry contributed a total of 158 points, and if we divided it by 7, the result is 22.57, and that will be the mean. The summation of x minus mu squared is equal to 497.68, and the square root of 497.68 over 6 is equal to 9.11, and that will be Curry's standard deviation. In conclusion, LeBron James obtained lower standard deviation and higher mean than Stephen Curry. We can conclude that LeBron James is much reliable scorer every night and giving higher points than Stephen Curry. Last and fifth example is about where to award the valedictorian between the 3 outstanding students. The data that listed below is the grades of 3 students that come up with the same general average. Who will be the class valedictorian in this scenario? The 3 students obtain the same summation of their grades, which is 768 and the n number of 8. Thus, 768 over 8 will be equal to 96, and that will be the mean or the general average of these 3 students. Having the computed GWA, the 3 students will have the same average. Then who will be the class valedictorian? Now let us solve for the standard deviation. First, for the student 1. If we minus 96 from all the grades of the student 1 and square it, we're able to get the summation of 16. The square root of 16 over 7 will be equal to 1.51, and that will be a low in standard deviation. Next, for the student 2, subtracting 96 for all x value, we would get the summation of 62. The square root of 62 over 7 will be equal to 2.98, and that will be a high standard deviation. Last, the student 3. The summation of x minus mu squared is equals to 12. The square root of 12 over 7 will be equal to 1.31, and that will be obtained a low standard deviation. By examining the output of every student, we can proudly say that the student 3 is the most deserving in valedictorian award than the 2 students, because the consistency of the grades of the student 3 get. These are the important things to take note in standard deviation. Standard deviation can measure consistency and reliability. It is also a key part of calculating margins of error. We also have to remember the low standard deviation means data are clustered around the mean, and high standard deviation indicates that the data are more spread out. We also have to take note that the lowest standard deviation is the most consistent. Thank you for watching. This is Lusterio of PS Psychology. I hope you learned something.